the share screen from my PC. But if I'm teaching for the true solution, I will be using my iPad. So here's the first questions. It's called make all distinct. You're given an integer exactly in the range from 1 to n to the magnitude of 2 to the 10 to the power of 5 as non-zero integers. And some of them might be overlapping. For those overlapping number, you got the operation allowed to move them k distance away from its original places. The input you will be given t test cases, and you will be only given 1k. That is, you're only allowed to move this k if the k is positive, then you're allowed to move it to the right. If k is negative, then you're allowed to move the collision number. And it's guaranteed that the sum of n over all test cases do not exceed 10 to the power of 6. I'm going to switch to my iPad for further walkthrough of this problem. So here are some of my observations for this problem. If you can see my screen clearly, I noticed that for any number, they can only move by k. So either if the k is positive, then if any two collision number happen on the number line, you can only walk k distance, step size of k. So if k is greater than 0, you can move k or double k. So it's only taking a step size of k. So if k, on the other hand, is negative, then when a collision happen, all you can do is move your point left to a step size of k. So the remainder does not change because for any number within the number line, you can basically represent it by using AI times k plus a remainder. So for any number within this given 1 to n, you can decompose it. Let's say this number is pi. You can decompose it into some multiply of k plus some remainder. If we represent every integer number in this range in this form, you will notice the allowed operation only allows it to move to, let's say, ai plus 1k plus ri. This is when you take one step. If you take two steps, this pi has become ai plus 2 times k plus the remainder. So I have noticed the remainder does not change. So when we're moving, whenever there is a collision happening in this range, I can choose to move the collision point k steps away, and the remainder does not change. So I should only be careful. The only thing I'm concerned about is after moving, let's say I'm down k step, I moved one operation. However, there is another number occupying my future moved 2 points. So my future definition. This is the only thing I'm afraid of. That is, I moved my number, but there is a collision in the future. So I have decided since the next point I move to will have the same remainder as me, I have decided to partition the number according to the remainders. Um, so as I notice, if there's a collision happen, I decide to move to the nearest untaken points. But the untaken points must have the same remainder as me. So I have decided let's sort the number from the smallest to the largest. This is when k is greater than 0, I decide to sort the number from smallest to largest. And I partition them into k groups. Because the k's are the possible remainders. The possible remainders you can have is going from 0 to k minus 1. I decided to partition the number into k groups. So for the k groups, some of the number may fall into the remainder group 0. So that means it's completely divide k. So some numbers fall into the group of remainder 0. Some of the number fall into the group of I have a remainder of 3. But why does this matter? Because first of all, sorted I have sorted numbers. The number, if k is greater than 0, then I sort the number from smallest to the largest. Then I know the numbers are strictly increasing. So for every number, I'm going to try to assign it to the partition remainder groups. And in the remainder groups, you will notice if there are collision happen because in the remainder group, I no longer store the number itself. I store the number floor divided by k. That means how many multiply of k does this number represent? So if two numbers, they actually reside in the same remainder group, and also their floor division is the same, that means there is a collision. Then I try to move to the next untaken spot within the same group for this collision number. That's basically the idea for this solution, and I'm going to give out a code planning for this code. So this is my code structure planning. I have T test cases, so I read in T. Now for each test cases, you will have this N and you will have the now I want to group the remainder by I want to group the number by remainder. So I will use a map data structure to stop the remainder and map to all the list of values that have the same remainder. So basically all I do is this is my remainder and then I append the number to this group. So I have my map, which is just like the visualization I presented before, you have the number. The only differences between k greater than 0, k smaller than 0 is for k greater than 0, then I will sort my number in ascending order. So I'm going to assign the number from smallest to largest. This is to avoid some number, if you're given the number in random order and you're trying to assign them along the way, along the fly, you might be taken the future position where the future patient position supposedly is going to be having another input number. So the best way to save your steps is to actually sort them ascendingly and assign the number one by one beforehand. So you know the next number is going to be for sure greater than the previous one. Either it's going to be in a different partition remainder group, or it's going to be taking a larger spot compared to your previous assigned number in the same remainder group. So this is a controlled and ordered way of assigning spots and resolving the collisions. At the beginning, the previous I assigned it to negative infinity because within the remainder group, none of the number has been assigned value yet. Let's give an example. So my n, I have, let's say, 10 numbers. My k is equal to 3. So let's take a look at one example I have created. Then for a sorted input, then you have 3, 9, 7, 12, 12, 15, 15, 15, 80. So you will have two groups, basically a remainder that is 0 and then a remainder of 1 for this 7. So I have partitioned them into remainder groups. This is sorted in ascending order group. Now for this 3, if you 4 divided by 3, it's 1. So that means 1 is taken, a multiply of 1 plus the remainder 0 is taken. Now this 9 comes, that means 3 is taken. 3 times 3, it's 9. Now when this 7 comes for the remainder of 1, you know 2 is taken. Now when this 12 comes, you know 4 is taken. What's interesting is when this 12 comes, I know 4 is already taken. So I need to find the next immediate spot greater than the previous 4, so I can move this collision 12 to the next available point, which is 5. Now for this fly, how many steps or how many operations I have added a k to? I added 1k, because basically this means I moved this 12 to 15. Now when this next 15 tells, if there is no previous child that taking its supposed like spot in this partition group, I should have put this 15 in the spot of 5. But however, since this 5 is taken, I should go and find the nearest spot who can represent this 15. Basically, this 15 is going to take the spot for 6. So I'm using 18 to return this 15. Now how many steps I have moved this 15? I moved one spot to the right. I used the operation one time. Now, when another 15 comes, again, since it's spotted longly taken, if there's no collision, it should be at the spot fine, but all the two nearest future spot have been taken, then this 15 is put in the spot of 7, and it have made 2 operations. So you can do this along the way and find this 15 is taking the spot for 8, and it moved 3 operations. And this 18, if there's no collision, it should be at 6. But the nearest spot I can put it is at 8. Basically, I'm using 27 to represent this 18. Now the step I have taken is 3. Now the total operations I do to resolve the collision is actually 10. Basically, this code is doing this process. How is it doing though? Um, for each value, that is for each value, for each number in this group, so I ask for my x, what is my current assigned value of this number? If the current assigned number should be greater because I have sorted the number in ascending order within the group. If it's actually greater, that means great, no collision happened. So I should move on to the next number. So I update my priv to be my current x. In the else cases, that is, oh, there's a collision happened because either someone else taken my point, or I'm in the case where the priv is equal to x. Two numbers are the same, or there was a collision happen like this 20. Um, this 20 is, oh, someone has taken my spot. So when it's 12 mid, the priv is going to be equal to x. So you're assigning the same number again. Or it's in the case where this 12 and 15 happened. This 12 basically is assigned to 21. And this 15 is now smaller than the 21 because it knows all the previous spot has been taken. So I should seek for future spot to represent this 15. So I ask for like how many distance I should travel and divided by the step size k I should be taken. Since the priv and x, they should not be overlapping. Um, I should add 1 to it to avoid overlapping between priv and x. So this is, imagine priv and x are the same, then 0 divided by the step size k means you need to move them 0 step. However, that's not the case. When priv and v are the same, that means you are given two exact same numbers. So you need to move at least 1 step. That's what the +1 is here for. Um, and the only differences between k greater than 0 and k smaller than 0 is you should sort your number in descending order when k is less than 0, since everything is moved to the left. Now, when you have actually find out the steps, then you update the steps, and then you should updating what the spot that has been taken by your previous number, because now they have the collision and this is the number of steps. You have decided to move the previous number, and now this priv is the final last number you have resolved the collision into. For example, when you resolve this collision for 12, you have actually represented not by 12 but by 15. Um, I want to stop here for any questions. You can open your microphone or type in the chat for questions.